So this is CSCI 447. We're doing our extra credit project demo, which is on a stacked autoencoder. So a stacked autoencoder is essentially just a feed-forward neural network with a hidden layer or multiple hidden layers that have fewer nodes than the input and output layer. So we're going to start with a short example. Here we're training our stacked autoencoder with just 4 data points. As we can see here, each data point has a 0 attribute for the last one. Because we have 3 attributes for each, we're going to start with an input layer of 3 nodes, and then we're going to compress it down to 2 nodes, and then decompress it back into 3 nodes, and see how that looks with this process. So as we can see, the first prediction is a prediction made before doing any sort of training, and then we're going to train for 10,000 iterations with a learning rate of 0.5 and 2 different batches, just some hyperparameters. And then we can see after that training, we're essentially just printing out the data points again to see if we've are able to compress and decompress them. So for the first point, this should map to 0, 0, 0. It's close, 0.36 and 0.37 is close, and then the last column seems to always be really, really low numbers, close to 0, which is promising as that's what our training data looked like. And then we can see 0, 1, 0 is really close to the second data point, 1, 0, 0, and then 1, 1, 0 represents there. So we're going to move on to training on one of our data sets for the project. We're going to be showing the machine data set. So essentially what's printing out, how we run our code is we first train a classifier, which is a perceptron on the raw data, which is here. That will give us kind of a baseline model for how well our network is able to predict in general. And then what happens is we train an autoencoder with 1, 2, this would be 1, 2, and 3 layers each, and then pass our data through that autoencoder and then try and classify that data to test regression and F-score and such on our data to compare to our baseline model to see how well we have been able to reconstruct our data. So what's showing in the output here, this first one is just a raw data point that has been untouched since the data preprocessing. We can see that these are the features and that it has a its class is 12. And then for the full data set, we have a mean squared error of 58 for this classifier that we've trained. So then we go through, we look at data that has been compressed and decompressed with 1 hidden layer, and our hidden layers are shown here right now for the machine data set. I believe we're using is we use 8 hidden nodes, and then for the second stacked autoencoder we use 6, and for the last one we use 5. So we can show compression there. We have been able to pretty closely map the original values with 1 single layer, and then as we can see the next one down, which would be 2 hidden layers or 2 hidden decoders, is not quite as good, but if we compare all of our mean squared errors, they're very similar, which shows that we have been able to pretty successfully compress and then uncompress our data without losing too much information.